we will be doing deep dive on PKI by Vault. So we will be creating our own CA. We will create a root certificate, we will create intermediate certificate and a leaf certificate. And here I have this demo Python demo application running, where right now you can see it is not secure. So we will create a certificate and try to use this certificate, and let's see if this works or not. So this will be like this. So our root CA, so starting from below, we have a leaf certificate which we will be using for our application, that will be issued by an intermediate CA, and that again issued by a root CA. So it's like top to bottom and bottom to top both, and I'll be following this, okay, page, build your own CA. So let's get going with this. Have you ever wondered, what's the certificate signer for Google, or what's the certificate signer for Amazon? So I just opened this. I'll show you how to check. So if you go and click here, connection is secure. Click here, certificate is valid. And here, if you see, so this is the certificate. Okay, so this is lib certificate, this is intermediate, and this is root. So if you go here and check who is the issuer, so you will see R3 is the above one, and so this is the hierarchy. So same if you go to Amazon and check, so you can see here, so this is the leap certificate, and the issuer is Amazon itself, and Amazon maintains its own CA. So same goes for Google. So if you go, this is the Google certificate, leap certificate, and if you check here issuer, so you can see it is Google Trust, and if you go to, so you can see it is Google Trust. So it is self signed, so Google CA is there. So same as Google and YouTube are both Google's product. So if you can see the both certificates are same. If you haven't ever tried, seeing the certificate, so please go through it, check what version it has, what certificate signing algorithm is there, the issuer, who is the issuer of this certificate, what is the certificate validity, what is the common name. And if you go to this subject alternative name, so you can see what is the DNS, what are the other DNS. So just to show you, you can see here, this is just random I'm picking. I'm not sure whether this will work or not, but you can see here connection is secure, and if you so you should see the same hierarchy, because this is the same certificate using by different applications. So if this is not working, doesn't mean that the domain itself is not working. So let's check one more. So if you go to, let's this data compute, datacompute.google.com. So you can see there is nothing hosted on this DNS, but the certificate is still valid. If you go here, and here you can see the certificate is valid. And the GTS, this is the root certificate, which are a part of your um, CA, trusted CA. So that's why you can see this valid symbol. So let's see in this video, let's explore how to create our own CA, and let's create a leave certificate and bind to this application. Let's see if things are working. This is gonna be exciting, guys, trust me. Okay, so I have divided the steps into this 1 2 3 4 5 6. So first is start vault. So let's initialize vault first. So I'm using the same steps. Okay, I'm using the vault in dev mode, and we'll unseal it. So the token root, you can see that the vault, I can go ahead with the vault now. Coming down to this, we will follow from top to bottom. So first we will create a root certificate, then we will move on to intermediate, and then we'll create lib certificate. So first let's focus on this root certificate. So I'm creating few folders, okay, like PKI root, PKI intermediate, and server. And the root certificates will be inside root, int certificate will be inside it. So okay, so these are folders got created, but these are empty folders. Now let's enable the PKI. So this is how I can enable it. PKI engine has been enabled. If I go here and try to search, you can see PKI has been enabled, but there are no certificates and configuration modified. So let's go ahead. Here I'm tuning that certificate, tuning that PKI engine. Okay, I'm setting the maximum TTL as this much, so this is like 10 years hours, so just tuning it. So right now the default is, I'm not sure what default is, so there is no maximum TCL right now, TTL right now. So let me, okay, the certificate, now the engine has been tuned. So if I go to this PKI and configuration, so I can see this maximum TTL is now 10 years. Okay, so now generate a root certificate. So what you do, this is the path where we have enabled the PKI engine, followed by root, generate, internal, and this is the common name. So in my case, I'm using my common name as this one. Okay, it's any name you can do. Just like here you can see they have chose to keep CNAME as here you can go subject CNAME as this one. Shouldn't be .com. Okay, it should be like this. This is also allowed. So here they have chose to this one Amazon root CA. So here I'm keeping like this rootca.com and issuer name is this one, followed by again 10 years, and here I'm you know exporting all the response into this PKI CA root.json. So let me done. So now if I, let's see what's there. So it was inside PKI root and this JSON. So you can see here it gave me this output. So this is my certificate, this is issuing CA, this is my key and all those. So if you want to check it from UI, if I go here PKI, and you can see this certificate got created, and this certificate, this is the certificate, and this is my common name. Issue expiration date was 10 years later, so it is 32, and like this. Moving ahead, now save the certificate in separate file. So right now it is in the JSON format. I need to be in CRT format. So I'm just parsing that JSON using JQ and parsing this data.certificate into ca.crt file. So .data.certificate, and it is self signed. Okay, this is the certificate which got created and signed by the self. That's why you must see this value and this value same. Okay, so let me copy this, put here, paste. So now cert has been created. So if I go to this my search directory, then in root and this is, so now you can see the similar cert we saw for YouTube, Amazon and Google. So this is the certificate path. Obviously I'll show how to get rid of this error, but right now just assume that certificate got created, issue is self, and SAN is this one. Now we need to set the CRL for this, so just executing this. So I'll now list which all the issuers I have. So if I go here and execute this, so it will show me this is the issuer I have. Now following this, now the root CA has been created. Okay, now let's move ahead for creating an intermediate certificate. These same steps we will follow. It's just we need to get it signed via root CA. So I'm deliberately keeping it open. Okay, so whatever the steps we have done via CLI, same we can do it via API. So this SH is just to replicate the same. Okay, so instead of passing it like this, okay, whenever we are doing that API call, so we need to pass those as a payload, and then so this is how we can achieve the same what we did but via API. So now let's focus on creating an intermediate certificate. So first we need to, obviously this is my certificate dedicated for root. I'll create one, I'll enable one more engine at this path PKI int, and that will be dedicated for intermediate. Okay, engine has been created. Now let's tune it. So I'm keeping it for 5 years. Okay, we should keep the root certificate as maximum as possible. Intermediate is less because we can have a multiple intermediate certificate as well, or we can, you know, modify this. We can replace this intermediate certificate with some different authority. So hence I'm keeping it as a 5 years. Done. So this is created. Now have a focus here. This is PKI int intermediate generate, and here we had this PKI root generate internal. So this is the difference while mm, creating an intermediate certificate. So here I'm keeping this issuer name is this one and common name is any name. Okay, and I am appending this data.csr to this .csr file. So CSR is like, you know, certificate signing request. So whatever the request we have, then we will be use this, we will send this CSR to my root CA, and that will give me the signed certificate for intermediate. So here let me execute this. Okay, CSR got created. Now let me sign the certificate. So this is like a certificate signing, okay, by CA. So here I'm giving a reference. So this is the most important line, okay, issuing reference. So let's assume here you can see we have given the name as Rahul Kinge root CA. Now here Rahul Kinge root CA. So instead of this, let's make a deliberate mistake. Okay, I'm doing it by a reason. So let's see if it should throw error. So let's see if it really throws or not. So to this, because there is no valid issuer by this name, this, so it should throw error now. That could not fetch this CA because there is no CA by such reference. Now this is a valid one, so we are now creating certificate, intermediate certificate. Okay, the path is cert PKI int. So if I go to cert PKI int, and if I see this, so this is this CSR we got created. We passed this CSR to root CA, and that retrieved me the signed certificate. So if I go here, I can now see this authority, that this is the just like here, you know, root certificate, then intermediate certificate. So if you go to details, it will show you that issuer is rootca.com. Expiry is again 5 years, and like that. So now we have a sign intermediate. Now let's do the remaining activity, after which we will try for a leaf certificate. So I'll go, let's set the CLR. This is how I can publish. Done. Now we have our root CA created, intermediate CA created. Now in we always create a role. Okay, we always create a role first. So if I show you from UI, so you can see this is my PKI, and there is no role created as such, but we have two signed certificate. You remember, one is self signed and one is for the intermediate certificate. So this is for the intermediate certificate and this is self signed. So same, if you go to PKI int, there is no certificate and there is no self signed certificate as of now, but you can see there is a role section. So we are now creating a same. So PKI int, okay, because we are following this hierarchy, our leaf certificate will be signed by intermediate, not the root. So that's why it is PKI int here. Now my vault role name, I'm keeping it as learn hub -role, and allowed domain is hub.com. Okay, So I'm just keeping those variables as environment variable. Now we'll create a role. Okay, so here again, just like I'm creating a role, my role name will be this one, and allowed name is this, allowed subdomains is this. Yeah, my role got created. Now if I try to read this role, okay, so now this is my role details, and these are my values. So if you have ever created CA, or if you have created any certificate via key tool or OpenSSL, so you must have observed that we need to pass on a street address or organization unit. What is my organization? So here we haven't set any, so that's why it is null by default. But this is the another role, okay, where I am deliberately keeping all those values. So let's finish first with this learn hub role, and then I'll show you again what happens if we set it by default. So now we have created the role. Now let's create a policy. Okay, we already had a session on policy, so I'm just giving whatever with this path. Okay, PKI int. So existing was only 2, now policy got created, and this is the new policy. Let's create one more role called MCU role, and let's read it again. So here you can see I set my organization is Marvel organization Unix unit, and this is my postal code, this is my city, these are the languages, all I can set it. My TTL of this certificate is 1 hour, after which it will expire. And so these are the details with that role. Now let's create a user. Okay, so it's like, this is different entity, I don't know about it. This is the middle one is the different entity, I don't know about it. But this is me as a developer, Rahul Kinge, who will request my CSR to intermediate CA that I need a signed certificate. Again, we have seen in the last videos, how to use this user pass to create users. So I'm just keeping my user. I'm enabling here the user pass auth method, and then creating this user. And this is the policy mapped, the one we have created just now. User has been created. So let's generate a certificate now. So I'm just using this variable that I need, um, just like we saw here for YouTube, we have multiple SANs associated. Okay, so SANs, I mean subject alternative name. So here I am keeping this alternative name as rahul.hub.com, kinge.hub.com, anything with hub.com, because you must have observed that while creating a role, we have said my allowed domain should be hub.com. So anything begins with star hub.com should work. So I'm keeping setting these variables. And now this is, now let me do Vault login with this username and password. So I'm deliberately not doing that manual thing. Okay, so I'm appending my user token to this file user.token, and then exporting via this. So this is how it should be done. I must see now a file user.token, and here is my token. So I have kept it now. So now if I do Vault token lookup, so it should show me who I am right now. So I am user pass logged in as Rahul, and I have this policy mapped. Okay, now let's read the role if I am able to read it or not. Permission denied. I wasn't expecting this. Maybe that Okay, okay, we haven't given access, so that's why. But anyways, it's not required. So let's, if I would have done something like, like this, so this wouldn't have thrown me the error. So I shouldn't have got that error. So moving ahead, so request a certificate. Now we are requesting a certificate, okay, that please issue me a certificate. So, and these are the values I already set here as an environment variable. Done. Now if you go to server, search and server, so this is my server test hub. So this is my chn, so this is common, this means this is my intermediate certificate and this is my root certificate. And now let's parse that JSON, and using JQ let's create one separate entity. So, and have a look here, I am appending because here I am creating issuing CA, so I am following this hierarchy. So it should include my root certificate as well as intermediate certificate, so that's why this is double appending. So I'll do this together. Done. So let's have a look. So now, so if I go to server and check this startup.com, so I must see now this hierarchy, okay, this testup.com, and this is the issuer. Okay, I need to add it. Okay, I'll do it. And intermediate certificate, and if I see this intermediate certificate, it is root CA, and followed by this issuer. If I see the certificate of this, the issuer should be my intermediate, and the intermediate is this one. So this is how my hierarchy is getting followed. Now my certificate is ready. Okay, but you remember one more role we have created for MCU. Let's request a certificate for that as well. Okay, here my common name will be avengers.mcu.com, and the alternate names could be Iron Man or Captain America.com. So okay, things got created. Now let's see here. So in this again, you will see the same hierarchy. Okay, but if you see here, we have added few more details, like 3 hours, the validity is for 3 hours, alternate name is, so you can see here the subject. Now it has given you the entire details for that certificate, that my CN is this one, organization unit is this one. So that is the advantage. Okay, so whenever I'm requesting a certificate, I should get the detailed information of my intermediate. So here you can see, while creating a role, I haven't set any by default, so that's why it retrieved me none. So if I check the same subject for the other certificate here, and if you go to here and check, so you can see we haven't set anything other than CA, but here we have set most of the things. So this is for more clarity. Now my certificate got created. Now I'm ready to use those certificate. So this is my, so I'm just closing down this is my Python application. Okay, so let me copy my certificates, having just application certificate location. So here I'm keeping these are the old certificate which got expired. Now here I'm keeping this, so these are the fresh ones. And let me enable the, okay, now I'm running it on my local host, and I'm giving this SSL context that my certificate and my key is at this location. So let's go. So here I have Python installed, so Python run.py. Fingers crossed. Okay, so now it is running on 443. So let's see, this was, so this was my application before. Okay, I'm Opening it incognito to get rid of any cache if there is any. Okay, it is HTTPS. And yep, you can see the certificate. Now I have this certificate. If you go, it is not valid. Okay, let's do this. Let's get rid of this in the next. So here you can see this is now it is throwing error because the root CA is not in my trusted CA list. So let's do one thing now. Let's go to this Chrome, to setting. I hope you are already aware. If not, pay attention. So this is the SSL management. So I go to my managed device certificate, intermediate, trusted root CA. So either you can do this import, okay, or do one thing to make your life simple. You know your certificate, right? It is here. Sorry, my root is this one. So what I'll do, I'll just double click on it, install certificate to this not current user, to my local machine, and it will ask for admin access, place, where to place. I know it is, I should keep it here as a trusted root certificate authority, and finish. Now let's kill the process and run it again. And let me just copy this URL, close my browser. We have created certificate for this avengers.mcu.com, and if you go to this server and see whether the things are working fine or not for this certificate. Now you can see the hierarchy is successful. We have added this root certificate, we have installed this root certificate as my trusted certificate. Okay, now if I try to launch my application, okay, it is already running, and if I see here, it is showing that it is running on HTTPS, but it shows certificate is not valid, but it has picked up the right hierarchy. Now we need to modify my host file. Okay, so I go to this directory, okay, Windows System 32 drivers etc, and I load this host file in admin notepad, and I'm just giving a reference that 127 is pointing to avengers.mcu.com. Now I'm copying this, I go to my browser here, https colon dash dash followed by this. So it should now show. Okay, now the website is running perfectly fine, and if we see the certificate, you see it is certificate is valid. Go here, and this is my hierarchy. So this is how we can achieve it. Few things left, like okay, so how to list your certificate. So this is how you list your certificate, this is how you read your certificate. Okay, and then revoke certificate, delete certificate, and destroy certificate. So these are the certificate CLI commands. You can go through it. Let's have a look from the UI. Okay, because there are things got changed. So and I'm keeping this root. So now I must see here, I should see the two entries. Okay, but here I should see two entries again, and these are the two roles we have created. Yeah, but if you go here, one is for my test.hub.com and the other one is my avengers.mcu.com, and this is the certificate. So pretty much for this PKI, I hope so. In this video we have created this hierarchy, okay, and created this avengers.test.com, and things worked as expected. You can see if you go here. So yeah, this is the hierarchy, and this is what we were trying to do. So we have kind of done the same .mco.com. So in the next session, so right now, here if you had paid attention, so the time frame we kept, it is for 1 hour. Okay, so what happens after 1 hour? So my application should throw me error that the application, the cert has been expired. So just to make it in automated way, I'll be focusing on this vault agent for PKI, so that will automatically renew the certificate and automatically restart my application. So let's focus on vault agent in the next section for both KV as well as PKI. Yeah, that's it. Stay with me. Thanks.
Thanks for watching my video. Please like, comment and subscribe. This will help me to work on myself.